Hi everybody, the purpose of this video is to do your homework in section 2 of chapter 5, the binomial distribution. And as you can see, we have our homework screen all set up. We have Hawks Learning right here, we have our calculator, and we have OneNote. And of course, I'm going to go into Certify. Notice that in Certify, we have 10 questions. You have to get 3 lives, so you have to get 7 of the 10 correct before the due date in order to get a 100 on your homework. Having said that, I would encourage you to do all 10 of these. Why? Because the questions you skip will most likely be the questions on the exam. As always, I'm going to do this through practice. So here we go. And this is our first question. Assume the random variable x has a binomial distribution with the given probability of obtaining success. Find the following probability given that the number of given the number of trials and the probability of obtaining a success. Round your answer to 4 decimal places. So we want to find the probability that x is greater than 7 for n trials with a probability of success of 0.5. So if we have 10 trials, then x can take on the values of 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. And the probability of x being greater than or equal to 7 is the probability of x taking on these particular values, 7, 8, and 9. And also remember, we have this function in our calculator called binomial or binom CDF, which is a function of n, p, and x. And this will be equal to the probability that x is less than or equal to a particular number, x. Okay? So we really can't use this function to compute this, but we can use it to compute its complement. Okay? And the complement of the set x being greater than or equal to 7 is going to be equal to the probability that x is less than or equal to 6. And based upon the complement rule, the probability that x is going to be greater than or equal to 7 is going to be equal to 1 minus the probability that x is less than or equal to 6. Okay? This we can compute using binomial CDF. So let's go ahead and go in and do that. Second, VARs for distribution. Go to binomial CDF. Okay, number of trials is 10. P is 0.5. And then in this case, x is going to be 6. And that gives us the response, and that means that this is equal to 0.828125. Okay? And then 1 minus that, well, to do that, we can do 1 minus, go ahead and highlight that, hit enter again, and that is our answer. 0.171875. Remember, we need to round this to 4 decimal places. Our 5th decimal place is 5 or greater, so we need to round up to 0.1719. And that should be our answer. There we go. Okay, next we want to compute the probability that x is less than or equal to 3, where n is equal to 6 and p is equal to 0.03. Well, that should be pretty straightforward because binomial CDF evaluated at 6, 0.3, and with x is equal to 3 will be equal to the probability that x is less than or equal to 3. So that is just, don't know how that happened. That is just a straight computation or use of binomial CDF. Okay, so I'm going to do this by hand again. Second, distribution. Find binomial CDF. There it is. Number of trials is 6. Probability of success is 0.3. and x is equal to 3. And that is our answer. We have 0.92953. 3 is our 5th decimal place. It's less than 5, so we do not need to round up. We should have 0.9295. Okay, now this one is we want to compute the probability that x is less than 2. Now to do this, we need to write down our values of x just to make sure we get this right. So x, since we have 6 trials, x can take on the value 6, 5, 4, 3, 2, 1, and 0. The probability of x being strictly less than 2 is this, or the event x being strictly less than 2 is the event of x being either 1 or 0. The point of the matter is the event of x being strictly less than 2 is equal to the event that x is less than or equal to 1. They both have the exact same elements, 1 and 0, and then of course 1 and 0. Furthermore, this right here is equal to binom CDF (6) 0.8 1. That should be a point, and that should be a parenthesis. Okay, so that is what we want to compute. Now I could go and do second distribution, or what I can do is go ahead and highlight the history. Here, right here is binomial CDF. I can hit that, highlight that, hit enter, bring it down, and go ahead and edit it. I don't need to edit the 6. We have 6 trials. I do need to edit P. That is now 0.8. And now n is going to be equal to 1. Okay, so there we go. We have n is 6, P is 0.8, x is equal to 1 because of our argument here. And that gives us 0.0016. And there's nothing to round here since there's already have 4 decimal places, so we just go ahead and type that in. Okay, next, assume that the random variable, okay, well, we've read that before. And now here we want to compute the probability that x is equal to 4 for the case where n is equal to 6 and p is equal to 3. So whenever you have the probability of x being equal to some particular number, that means you want to use binomial or binom, not CDF, but PDF. PDF stands for probability density function. CDF stands for cumulative distribution function. And of course, that will be NP, whatever x is. So in this case, we want the probability of x being equal to 4 is going to be equal to binom PDF 6 0.3 4. So we really can't use this one. We have to go back into distributions and find the correct one. It should be right above binom CDF. There it is. Hit enter. Put in our values. 6, enter. 0.3, enter. 4, enter. Paste, enter again. And there we go. We have that this is equal to 0.05935. 1, 2, 3, 4. This is our 5th decimal place. It is 5 or higher, so this is going to round to 0.0594. And there we go. All right, next. Assume that the random variable x has a binomial distribution with the given probability. Okay, we read all that before. We want to compute the probability that x is greater than 3, where we have 4 trials and p is equal to 0.4. Okay, so x can take on the values 4, 3, 2, 1, and 0. There's only 4 trials. These are the possible outcomes. The event of x being greater than 3 is this value right here. So there's 2 ways that we can compute this. One is the probability that x is greater than 3, strictly greater than 3, is equal to the probability that x is equal to 4. Okay, the other way we can do that is by using complements. Okay, remember, if this is the event x being greater than or strictly greater than 3, then this is its complement. So the complement of x greater than 3 is the set x of all x's where x is less than or equal to 3. Okay, and then the probability of x being strictly greater than 3 using our complement rule is going to be 1 minus the probability of its complement, namely x is less than or equal to 3. So we have two ways of doing these. Now this right here, I didn't want to do that, this right here is binom PDF for 0.44. This right here is binom CDF, n which is 4, 0.43. So we would have 1 minus that. This actually should be a 4 up here as well. Okay, so let's try these both ways. So for the first one, we're going to use binomial PDF. We're going to use this right here. I'm sorry, I'm kind of running into myself. Okay, the probability that x is equal to 4, namely this. All right, we can go ahead and use our history here because we have binom PDF right there. So we can go ahead and highlight that, hit enter, brings it back down. And we have to change 6 to a 4 because we have 4 trials. P is 0.4, so we got to change that. And x can stay as 4. And that gives us 0.0256. Well, what if we did it the other way? Well, first we can compute binomial CDF, second distribution, go figure out where that sucker is. There it is. 4 trials, 0.4 for P, x value is 3. There you go. And then 1 minus that value is the exact same thing, 0.0256, 0.0256. So the point of the matter is there are two ways to solve this particular problem. Just recognize that if x is greater than 3, it has to be 4. Compute the probability of x being equal to 4, or use your complement rule. It's entirely up to you how you choose to approach that. Oh, I need to get the other 0 there. There we go. And there we go. We are halfway done. Determine whether or not a given procedure results in a binomial distribution. If not, determine why the determinant is not met. We're going to survey 37 people to determine which brand of apparel is their favorite. So remember, a binomial for a procedure to have a binomial distribution, each trial must have 2 outcomes, either success or failure. That's it. Can't have any more than 2. If there's more than 2, it does not follow binomial distribution. Now, as far as apparel is concerned, there's lots of different brands. There are, and I'm going to show you my ignorance relative to apparels, but here it comes. There is Levi's. There is, I don't know, Gap. There is Ralph Lauren. And I'm sure there were others. Obviously, there are more than just 2 brands of apparel. So our answer here is going to be no. And why? Because there are more than 2 possible outcomes. Now, these are the other options, but if the answer is no, then chances are that it's going to be that because there's more than 2 possible outcomes. And that brings us to 7. A student takes an exam containing 5 multiple choice questions. The probability of choosing a correct answer by knowledgeable guessing is 0.6. And so that if the student makes knowledgeable guesses, what is the probability that he will get exactly 12 questions right? Okay, so we have 2 outcomes. It's either right or wrong. The probability of this person getting a correct answer is going to be 0.6. There are n trials, or n is equal to 15, and we want to know the probability that x is equal to 12. And that's what we're looking for. Okay, so here we're going to use binomial PDF. where n is equal to 15, p is equal to 0.6, and x is equal to 12. So second distribution, go to binomial PDF, hit enter. Okay, we have 15 trials, p is 0.6, and we want to know the probability of x being equal to 12. And there is our answer. We have 0.06338 and some more answers. And some more numbers. Now notice our fifth decimal place is an 8. That is 5 or greater, so we need to round up, and this will round to 0.0634. Okay, and there we go. Question 8. A certain insecticide kills a certain insecticide kills 60% of all the insects in laboratory experiments. A sample of 12 insects is exposed to the insecticide in a particular experiment. What is the probability that exactly 6 insects will die? Okay, so here, the first phrase, kills 60%, tells us what the probability of a kill is. P is equal to 0.6. 60% as a decimal is 0.6. We have our sample size, the number of repeated trials, is going to be equal to 12. All right? And we want to find the probability that x is equal to 6. That's what exactly means. And of course, that is going to be equal to 12 take 6 times 0.6 to the 6th times 0.4 to the 12 minus 6, or, well, let me just write that as 12 minus 6, which we can see that is equal to 6. That is also binomial PDF 12 0.46. So let's go ahead and do that. And actually, we can just go ahead and use our history here. Highlight binomial PDF, bring it down. We want to change the 15 to a 12. All right, 0.6. We want to change, actually, I made a mistake here. That should be a 0.6 here, not a 0.4. Leave the 0.6 the way it is, and then change the 12 to a 6. We can do that by doing 6 and then just hitting the delete key. Okay, hit enter, and that should be our answer. Our answer is going to be 0.17657. Our fifth decimal place is 5 or greater, so this is going to be 0.1766. All right, moving on. A real estate agent has 12 properties that she shows. She feels that there is a 50% chance of selling any one property during a week. The chance of selling one property is independent upon the other property. Okay, that's kind of important. Compute the probability of selling no more than 6 properties in 1 week. Round your answer to the nearest 4 decimals. Okay, so the real estate agent has 12 properties to sell. That tells us what our random variable x, or what values our random variable x can take on. It can take on, I'm going to need more space than this. There we go. They can take on the values 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, or 0. Okay? The probability of selling an object is 50, or of a property is 50%, which as a decimal is 0.5. And we want to compute the probability of selling no more than 6 properties. So that would be 6, 5, 4, 3, 2, 1. We want to compute the probability that x is less than or equal to 6. Okay? That's going to be equal to binomial CDF, where n is equal to 12, p is equal to 0.5, and x is equal to 6. So let's go ahead and do that. Second distribution, find binomial CDF. Hit enter. Okay, number of trials, 12. Probability, 0.5, x value is 6. And we have 0.6127 9. Our fifth decimal place is a 9, so this is going to round to 0.6128. That should be our answer. And this brings us to our very last question. A student takes an exam containing 15 multiple choice questions. Oh, I think we've almost done this one already. The probability of choosing a correct answer by guessing is 0.6. It means he guesses well. If the student makes knowledgeable guesses, what is the probability that he will get less than 11 but more than 8 questions right? That's going to be an interesting one. Okay, so X can take on the values 15, 14, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and I'm going to put the 0 over here. So and we want to know the probability that he will get less than 11. All right, well, that is going down to here, but more than 8, which would be right here. Okay, so the event of X being greater than 8, or less than 11, no, greater than 8, and less than 11 is equal to the probability of X being 9 or 10. Now, once again, there are two ways to do this. The probability of X being greater than 8 and less than 11 is equal to the probability of X equals 9 plus the probability of X being equal to 10. The other way that you can look at that is as follows. This right here is the probability of X being less than, or is the event X being strictly less than 11. Okay, and if we compute the probability of X being less than 11, which is the same as the probability of X being less than or equal to 10, we will get the probability of all these values. This right here is the probability is the event X being less than or equal to 8. This should be less than 11. Sorry about that. And we can write the probability associated with that of this right here, the probability of X being less than or equal to 8. Okay, so it should hopefully, you should realize that if we computed this, probability of X being less than or equal to 10, and then if we subtract from it all of this, what we have left is the probability that X is strictly greater than 8 and strictly less than 11. Okay, so basically we can compute this using binomial CDF, NP10 minus binomial CDF, NP8. Or we could compute this, if you come up here, using this right here. Okay, and that is going to be, okay, once again, that is, let me go ahead and rewrite that. That is that the probability of X being strictly greater than 8 and strictly less than 11 is equal to the probability that X is equal to 9 plus the probability that X is equal to 10, which of course is binom PDF at, to abbreviate this even more, at 9 plus binom PDF at 10. So they both should give us the exact same answer. Let's go ahead and find out. Okay, so second distribution binomial CDF. Number of trials is 15. Probability of success is 0.6. And we want to do 10. There we go. Let's highlight let's go ahead and use this history. And now we want to change the 10 to an 8. Delete 8. And then their subtraction, let's highlight this. That is 10 minus the one right above it. And that gives us 0.39255. Let's go ahead and write that down. That's what we get from this. Okay, now for the other one, the other approach, this approach where we're going to compute the probability that x is equal to 9 plus the probability of x being equal to 10. Second distribution, or VARS, binomial PDF. Now the number of trials is still 15. P is still 0.6. X is 9. Enter, enter, enter. That's that value. And then let's do the exact same thing for 10. 1, 0, parenthesis. Add those two together. 0.2, enter, plus the one right above it. And notice, it's kind of hard to see here, but we have the exact same value, which is what we were hoping for. Okay, so they both produce the exact same value. So our answer for this particular case is going to be 0.3925 because our fifth decimal place is less than 5. We don't need to round up. And that is how you do this particular homework. I apologize, this is typically longer than what I expect, but as you can see, the last problem was somewhat involved. As always, if you have any questions, please feel free to contact me. This is Bob Boyle, signing off.